Alright guys, let's flip this geometry class. We are going to do some instruction right now on dividing line segments, identifying transformations, rotating shapes, reflecting shapes, and dilating triangles. You guys ready? So this dividing line segment is on the park test, should we have a park test this year. And it's ratios, right? So don't forget that if my tab is upside down. If we multiply a ratio times a whole amount, we get a part. Right? Ratio times whole equals part. So we always have to figure out what if the ratio is a ratio of the whole to part, or sometimes it gives us the ratio of two parts, and then we want to switch it around so that the denominator of the ratio is talking about the whole segment. Okay, so what are the coordinates of B on AC such that AB is 3/4 of AC? So here we go, we want B somewhere on there. Where is it? So that AB is 3/4 of AC. All right, so it's not there, but it's somewhere on that line. So it's probably right about here. Okay, so what we want to do is we want to find the two distances separately. So we want to find the horizontal distance, and we want to find the vertical distance. And then we're going to multiply those by 3/4, and then we'll have our point. Okay, so the horizontal distance from A to C is 1, 2, 3, 4, 5. And the vertical distance is 1, 2, 3, 4. 4. Okay, so that is the whole distance, right? That's the whole way from A to C, horizontally and vertically. Okay, so what we want to do is we want to do 3/4 times 5, and we want to do 3/4 times 4. Well, I'm going to start with this one because that's easy. 3/4 times 4 is 3. Okay, so the vertical distance to get to the 3/4 point is only up 3. 1, 2, 3. So it's probably right here. Okay, now the horizontal distance, 3/4, is going to be 15 over 4. 15 over 4 is 3.75. Is that right? Okay, so then what we do is we just say, okay, we know that we would have to move over 3.75 and up 3. So from A, which is A is the point -2, -3. And in order to get to the 3/4 point, we are going to have to add 3.75 to the horizontal, so 3.75 to X. And we're going to have to add 3 to the vertical, so add 3 to Y, because that's the vertical. So -3 plus 3 is 0, like I said. And -2 plus 3.75 is 1.75. All right, so it's 1.750. Now there are some more difficult problems in this assignment, and I expect that you'll be asking me questions about them, and we can have a riveting conversation in class. Let's move on. Identify transformations. So I always illustrate transformations with my hand and waving. Okay, so go ahead and put your hand up and let's wave like a reflection. This is a reflection. We can also wave like a transformation. Robot wave. Hello. We can also wave like a rotation. Another robot wave. Rotation. And the creepy one is the dilation wave. Hello. That's when the size changes. It's really weird. Who waves like that? Okay, so in review. Reflection wave. Translation wave. Rotation wave. Dilation wave. Okay, so let's now identify what we have here. This A is reflected to B, that's a reflection right there. And here, that A has rotated. It's like the orientation is turned, and that's how you know it's a rotation. And then this is a dilation. See, A is huge and then B is small. And so the size change. Wait a minute. I think that maybe I cut off D because this is most definitely a dilation. All right. So those are the different transformations. And let me say one more thing about these before I move on. Rigid. Did I spell that right? Rigid. There. That's, well, you know what I'm saying. Rigid. Okay, so the rigid transformations are reflections, translations, and rotations. You think I could be a YouTuber? And those are called rigid because this, the shape is still congruent after the transformation. But then with the dilation, there's a size change, so that's not rigid. That would be non-rigid. Okay, now rotating shapes. Well, I yelled at Busoye in week 1 for Googling things instead of asking me, but with rotating shape rules and reflecting shape rules, Googling is great because these are some rules that you gotta memorize, but rather than just write them all out, I just found another teacher that already did that. So we have these 90-degree rotations in the coordinate plane. Okay, so there's 90, 180, 270, 360 would be all the way around back to where you started. And it's important to note that counterclockwise is positive. So can you tell me what the negative rotation would be? If you say clockwise, you're very right. Clockwise is a negative rotation. And so if you rotate, rotating is the capital R, 90 degrees is equal to a rotation of negative 270 degrees. Or a rotation of 90 degrees clockwise, rotating 90 degrees clockwise, is the same as rotating 270 degrees counterclockwise, you know. And the same thing is true with a rotation of negative 90 is equal to the rotation of positive 270. And so those are different things that you want to make sure you know. So now is rotated 90 degrees. Okay, so in order to rotate now 90 degrees, what we're going to do is take every coordinate, you know, the 3 vertices, and we're going to use this rule. So what does this rule say? Well, that's what the teacher wrote it right here. Switch X and Y and make Y opposite. So for illustrational purposes, W is at -2, 1. So we're going to rotate it, capital R, 90 degrees. And so that means we're going to, oh, and when you transform, then you put a prime. This apostrophe is called a prime. And the new point is W prime. If the old point is W, the new point is W prime. I'm going to make this a little less sloppy. W prime. Okay, so W prime would be switch the X and the Y, 1, 2, make Y opposite, and Y is 1, so like that. Okay, let's do it again with N. N is over here at -7, -3. Okay, so we're going to rotate that, capital R, 90. And so N prime would be -3, -7. Switch the X and the Y, and then make Y opposite. So Y was -3, so that's +3. So N prime is at 3, -7. Well, let's not stop there. Let's do the last letter, O. O is -5, 4. So we're going to rotate it, capital R, 90 degrees, O prime, switch them, 4, -5, make the Y opposite. Ta-da! Now when we graph these 3 points, and I'm going to do that, -1, 2, okay, there's -1, 2, that's W prime, N prime is 3, -7. So this does not feel right, but it feels like this is not going to be right. O prime is -4, -5, -4, -5. Okay. -4. No. And all right. So now is that right? So then W was at -2, 1, and then we switched it. Oh, did I say 2, 1? Well, how come no one stopped me when I said 2, 1? All right, well, it's not at 2, 1, it's at -2, 1. All right, guys, you gotta catch my mistakes there. But you know what? I did that for a reason, so that you all could see that sometimes the shape doesn't look reasonable. And sometimes when you do your math at 11 at night, it's going to come out a little wrong. So -2, -1, -1, -2. Okay. Well, that looks better. Okay. So now this thing is rotated 90 degrees. So that's that right there. Okay. Good. I wonder how many people were watching that thinking he made a mistake, he made a mistake. All right. Reflecting. Reflecting is a little bit easier. So the rules of reflections, and the reflections are a little r for the notation. So reflecting over the x-axis, and you can reflect over the y-axis. You can reflect over the line y equals x. So when you do that, when you reflect a point over the line y equals x, I'll just say, I'll just write it like this. You reflect xy over y equals x, you get y-axis. So they switch places. When you reflect over the y-axis, then the x-coordinate changes sign. And when you reflect a point over the x-axis, the y-coordinate changes sign. That's how you go. So if we reflect A, B, C, D over the x-axis, then we're just going to label each point on the original figure. So A is 1, 4. So A prime would be over the x-axis. We got to change the y. 1, negative 4. There's A prime. And so on and so forth. You just do all 4, connect the dots. You can ask any questions if you have any. Now the last assignment is about dilating triangles. Traditionally, students get low scores on the dilating triangles assignment. So let's look at it here. When we dilate, we have a center, so dilations. You identify your center, and then the distances from center, and then you get your scale factor, and you just multiply. Okay, that's all you gotta do. So the scale factor is the distance, the change in the distance away from a center. So if your original figure has a center and then you have a new figure that's going to be twice as big, then every point on that new figure is going to be twice as far away from the center as the original point. So my head is the center. See, now everything is just same distance further on either side. So here we have our original figure, and we are our scale factor is 4. So how far is A away from this center? Well, it's 1 away. So A prime is going to be, if A is 1 away, then we got to do, so for A, we got to do 1 times 4. Distance. And so now we got to go 1, 2, 3, 4. That's where A prime is. How far is B? It's 1, 2 away. B's distance is 2, so we got to multiply that by 4. You get 8. So B is going to be 8 away. 1, 2, 3, 4, 5, 6, 7, 8. Now it's possible that a point is like 2 over and 3 up. Well, then you got to multiply both the horizontal and vertical by the scale factor to get the image point. That's what it's called. These primes are called the image, and the points on the original figure are called the pre-image. We'll talk about that in class. Okay, so C is 2 up. So we're going to multiply that 2 up by 4 and get 8. So just go 8 up. 2, 6, 7, 8. Who do we appreciate? Mr. Field. 2, 3, 4, 5, 6, 7, 8. Okay, there. Let's use see if our line tool can help us. All right. Well, there we go. We did all of them. So I hope that you guys are able to do them all as well, and post any questions you have on Google Classroom, and I'll see you on Monday or Tuesday.